The focus of this lesson is automobile transactions. Example 1. Rod was doing an internet research on the number of gasoline price changes per year in gas stations in his country. He found the following graph called a stem and leaf plot. What are the mean and median of this distribution? First thing I want you to recognize is how a stem and leaf plot works. In this particular stem and leaf plot, the tens place is located on the left-hand side. So everything over here is the tens place. And then on the right-hand side, our leaves are our ones place. So for example, when I see a 1 and a 1, that's 10 and a 1 or 11. If I see a 1 and say a 9, that's a 10 and a 9 or 19. If I see a 4 and a 0, that's 40, and so on. And that's basically the setup. The number of numbers is found by counting how many ones places we have on the right, and then these tens places just divide them into rows. Okay, so in order to find the mean, we want to find the average of all of our numbers. Now, as you can see here, there are quite a few numbers. So what we're going to do to just kind of simplify this process is let's find the sum of each row, and then we will combine all of the rows, okay? So if we look at the first row, we have 11 plus 11 plus 12 plus 13 plus 17 plus 19, okay? So I know it seems a bit tedious, but we'll use a calculator, right? So we have 11 plus 11 plus 12 plus 13 plus 17 plus 19. Okay, so our first row has a sum of 83. And I think by doing it one row at a time, you're less likely to make errors. Okay, our second row is 20 plus 23 plus 26 plus 26. So that has a sum of 95. Our third row is 38 plus 38 plus 39 plus 39 plus 39 plus 39 plus 39. Lots of 39s in there, right? So that takes us to 271. And then 40 for that fourth row. And then our fifth row is 52 plus 52 plus 54 plus 55 plus 55 plus 55 plus 56 plus 57, or 436. And then our sixth row is 63 plus 64 plus 64, or 191. And then our seventh row is just 72. Now remember, to get an average, we want to find the sum of all of our numbers and divide by how many numbers there are. So now let's find the sum of all of our rows. So we have 83, 95, 271, 40, 436, 191, and 72. So that's 1,180, okay? So far we have our mean is going to be 1,100, and let me look at that one more time. That wasn't that one. Let's try that one more time. I have a whole bunch of calculators open. So 83, 95, 271, 40, 436, 191, and 72, 1188. 1188 divided by how many numbers are there? So we're going to count really quickly. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 data points, 30 numbers. So we'll divide this by 30. So let's take our calculator and let's divide our 1188 by 30, and we get a 39.6. So, or sorry, yes, 39.6. All right, so that is our average, and that is our average gasoline price change, the number of gasoline price changes per year. So we would say then, on average, the gasoline price changed about 40 times per year. It's quite a few changes, right? Okay, now the median is just the middle, right? So It is that number that divides the bottom half and the upper half of the data. So we know that there are 30 data points in this data set. So what we're going to do is let's count 15. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then let's look on the other half. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so our middle is actually going to be right here. If I go here, there will be 15 below, and then there will be 15 above. Okay, now that means our middle or our median is between 39 and 39. Well, the average of 39 and 39 is 39. So we would then say that the median number of gas price changes during a year is 39 times. Now it's your turn to try. Try this. Find the range and the upper and lower quartiles from example 1. Example 2. Rod, who was researching gas prices in example 1, found another graph called the box and whisker plot or box plot. It is shown below. Find the interquartile range of this distribution. Okay, so the way a box plot works is this. The minimum value is found at the left end of the left whisker. So we're going to say that this 11 represents the minimum or the lowest gas price. So this here is our minimum. The maximum is found at the right end of the right whisker. So each of these lines is referred to as a whisker. So these are whiskers. Okay, this one too, whisker. Now, this middle number is referred to as our median, or also Q2. And then the middle of the minimum and the median is our first quartile, or Q1, and then the middle of our median and maximum is our Q3. Now, if you remember from the last lesson, the interquartile range, or IQR, is the difference between Q3 and Q1. So in this case, our interquartile range is going to be the difference between 55 and 23. So 55 minus 23 is going to give us 32. Okay, so the interquartile range of the gasoline prices is 32. Now it's your turn to try. Try this. Based on the box and whisker plot from example 2, what percent of the gas stations had 55 or fewer price changes? Example 3. The following box and whisker plot gives the purchase prices of the cars of 114 seniors at West High School. Are any of the car prices outliers? Create a modified box plot, a plot that shows all outliers as single points past the whiskers. So based on what I'm seeing here in this graph, my assumption is that there is an outlier. And the reason I'm saying this is the way the box and whisker plot works is each quartile or each set of the data is represented by a box or a whisker, right? So we know that this here is 25% of the data between the minimum and the first quartile. This is also 25%. This section here is 25%. And then this is here is 25%. And whenever you have a box or a whisker that is much longer than the others, the data is often considered to be skewed. Skewed means pulled in a direction that is different from the rest of the data, right? It makes it look like the average is much higher, right? Or that the spending on cars is much higher than it actually is. So we're going to try to determine if this $43,000 car is abnormal, is an outlier. All right, so what we're going to do is we're going to determine where our lower and upper bounds are. So if we remember from before, our lower bound is going to be determined by looking at Q1 minus 1.5 times our IQR. So in this case, our Q1, let's label everything. So we have our minimum. Let's use a different color. So that's our minimum. Q1, Q2, Q3, and Q4, aka the max. Okay, so our Q1 is 5,200 minus 1.5 times our interquartile range. Remember, that's the difference between Q3 and Q1. In this case, let's calculate that. We have a difference between 9,100 and 5,200. So that's 3,900 for our IQR. So 3,900. And then let's calculate. So we have 5,200 minus 1.5 times 3,900, which is negative 650. So unless the car is negative $650, we don't have an issue with the lower bound. Our upper bound is Q3, so third quartile plus 1.5 times the IQR. So in this case, that is, what's our Q3? 9,100 plus 1.5 times our interquartile range, 3,900. Use our calculator. So 9,100 plus 1.5 times 3,900. That's 14,950. So 14,950. So that's considered our upper bound. So as long as the car price ranges between negative $650 and $14,950, it is not considered an outlier. So then the question is, do we have a car that falls outside of this range? And we definitely do. We see this maximum here, that $43,000 car falls outside of the range. So what we're going to do now is we're going to create what's called a modified box plot. Okay, so I am going to erase some of this just to give us some space. Okay, so let's get rid of some of what we have here. And I'm going to leave my upper bound because that's where we have our outlier. So what they want us to do is create what's called a modified box plot. Now, the way this works is everything will stay the same except our outliers, and our maximum will change because we have an outlier in the upper part. So I am going to redraw our box plot. Everything's going to look the same except we're going to stop where that new maximum is. That 14,950 is going to be here. We'll still have everything else the same. Our 9,100, our 7,000 for our median, our first quartile at 5,200, and our minimum at 3,000. Now what we're going to do with that outlier, that 43,000, is we're simply going to put a mark, a star, a point that represents it. So we're going to go all the way across to where the $43,000 car was, and we're going to draw a little mark. Just put a little asterisk here. And I think I want to use the same color that I had before. So we have this down here, exact same location, 4,300. And then this here is our modified box plot. And you'll notice that it has the same values as the same quartile, same minimum. The only thing that changes is we have this, new maximum, and then the old maximum becomes this kind of asterisk, this single point past the whisker. And there we go, modified box plot. Now, ultimately, if you had a data set that showed more seniors, other ones of the 114 seniors, and we could see a full data set, we might be able to mark multiple outliers. Now it's your turn to try. Try this. Examine the modified box plot. Is 400 an outlier? Explain.